0. It is known that f of 0 is -4 and that p1 is negative 3. Show that f prime of 0 is 2. So what do you have to do for part A? What's the first thing you should do? Yeah, write the nth. Pn denotes the nth degree Taylor polynomial. So can someone tell me what the nth degree Taylor polynomial is about 0?
F of 0 plus
Yep.
f prime 0x plus f double prime 0 over x.
F prime double prime 0, yeah?
Over 2x squared.
Yep.
Over 2 times x.
Over what?
Over 2.
Like this? Plus what?
F triple prime.
0 x cubed over, can you shut the door somebody? 3 factorial and so forth, right?
Yes.
So it says f of 0 is what?
-4.
So can we start plugging things in?
Yes.
So what do we have here? So it's a -4 right here.
Yes. Plus 2x.
And so then f prime of 0 is what? 2. So we have 2x like this.
Yeah.
Plus, and what do we're supposed to show, and we're supposed to show that we're supposed to show that, this is what we're supposed to show. We can't put that in there if we are supposed to show it. So how do we go? We know that's -4, but so what do we do for everything else? So we know that P1, so when you plug in a half, what do you get? Prime of 0, and what's x gonna, what do we plug in for x? 1/2, but we know that this whole thing equals what? -3. So you know f prime of 0 times a half is equal to what? 1. So therefore f prime of 0 has to be what?
1/2.
No.
Or
2.
2.
Close. Finish it. Okay, so that was just simply them getting you to write the Taylor polynomial. Are we okay with this one? Okay. Let's do part B. It is known that the second derivative at 0 is -2/3 and the triple is 1/3. Find P3 of x. So how do we go about doing this one? Well, what is P3 of, what's the general for P3 of x? What's that going to be? F of 0 plus f prime of x plus, oh, is it the same thing of what I just wrote up there?
Yes.
It is the exact same thing. I just stopped at the same place we want to.
F double prime 0 times x squared.
F double prime is 0, thank you, times x cubed all over 3 factorial. So can we plug things in now? Sure. So we know that P3x is going to, what's f of 0? -4. And it's not f prime of x, it's f prime of 0, sorry. What's f prime of 0?
2.
Plus what? Oh, and it's an x right there. I don't know why I dropped that. Plus 2x, right?
Yes.
Plus, and then what do we plug in there? -3
3
x squared all over 2 factorial plus
1/3
times over
3 factorial.
3 factorial. Now here's the thing. I didn't check the answer key yet. You might have checked the answer key already. Do they simplify that down? They probably simplify that. You check the answer key? I don't think they leave compound fractions like that. What are they? Plus, yeah. Why am I taking the time to write this out again and again and again?
To repeat it.
Yeah, you absolutely will have to do this a bunch of times. Excellent. So then what do we plug in for x?
2x.
So we know Pn of 2x is equal to what? Well, f of 0 plus f prime of 0 times 2x plus
F double prime 0 times 2x all squared.
times what?
2x squared.
Over 2 prime plus
F
triple prime of 0 times
2x all cubed.
all over
3 factorial.
3 factorial. Nice. So it's saying that h prime of x is equal to f of 2x. Okay. So that does this help us?
Yeah.
How so?
Now you know that that's h prime of x.
So this right here is h prime of x.
Yeah.
So this equals h prime of x. So what is it asking you for?
H of x.
H of x. So what do you have to do to go from here to here to the next?
Try integrating.
So you integrated. I'm curious. I'm going to check this here to see if this is how they. Yeah, they give you 2 methods. I think one of them will probably involve.
It's the other method that I don't understand.
Okay. So you want to know how they did it the other way? Sure. So let's see what they say here. So the first one is. So they're calling their answer Qn of x, right? So h prime of x is f of 2x. So, got it. Look at that. So then they do. Oh, I see. So look what they do here. So this right here, that's what we did, right? Whether we set them equal to each other. So then what do we have up here? If we plug everything, I mean, the thing is, okay, kids, what do we already have right here? What do we have right there? We have the third. We don't have to keep on doing the work over and over again. I was a little too happy about writing it again. Do we already have the third degree Taylor for this for P3 of x? So what can we plug in straight into there? What can you plug in for x to do part C? We could just plug in 2x right there. And then what do? That's what they do there. They plug it in, and this is what they get, right? It's like that is when you plug in 2x into this, what do they get? They get this thing. And then how do you get from here to here? What do? You integrate to go from there to there. So this right here is the method we're doing, but here's the thing. So I guess this is, if you want a top 10 things to remember, parts A, B, C, D, E, whatever, in a free response, are they going to generally be linked together in some way? Yeah, absolutely. So they gave you this. They gave you knew what this was going to be by just plugging in 2x. By just plugging in 2x. That's what we got right there. Does that make sense, everybody? Yeah. So it's 3, yay, exciting. So then what do you have to integrate, and then what do? They have to use the initial conditions, and then they simplify right here. What's the other way? So Ali, I think you were asking about this second method right here?
Yeah.
Emily and Brenna, can you tell me what they're doing on that one? What's going on that one? So in this one
Differentiating alpha of 2x.
no, well they have to. Why?